Okay, here's problem number 2 on the ditto that's called Doug. And I started by plotting points that were pretty from -1 to 3, which were these 3 locations here, here, and here. And now I have to make 3 rectangles using left-hand endpoint rectangles in this gap that's 4. So if it's 4 wide and we have to make 3 rectangles, each rectangle is 4/3 wide, or 1 1/3. So the left edge will be there. If I go 1 1/3, it's about there. Go another 1 1/3, it's about there. Another 1 1/3 is here. When you draw left-hand endpoint rectangles, make sure you slide up till the top left corner hits the graph, slide across, and then back down at that next gap so that every rectangle hits the graph in the top left corner. Oops. The area of rectangle number 1, which I'll just put here, I always go left to right, has a width of 4/3. It's kind of easier to keep it as an improper fraction. And its length is the y value of this dot right there, because the y value of that dot would be how tall this rectangle is. So we need to find that y value of that dot that's on this graph. And to find that y value, you plug this x value, which happens to be -1, into the original equation. And that's what I'm going to write. Not going to solve it. We already know what the answer is. We can see it's pretty obvious on the graph. But writing it like this helps us do sigma notation. We're going to add that to rectangle number 2. And the width of rectangle number 2 is also 4/3. And now we need to plug in the x value. It's either this one or this one. That'll tell you how tall it is. And we're looking for that height right there. It has to be on the graph. That dot right there is on the graph. So in order to find that y value, we would need to plug this x value, which is 1/3, into the original equation. So that's what I'm going to write. 1/3 plugged into the original equation is that. So this is just the width of the rectangle times the length of the rectangle, which is the area of that rectangle. Let's go ahead and do the last one, which is also 4/3 wide. And this x value right here would tell me how tall it is. And that guy, if you added 4/3 to 1/3, you would get 5/3, or 1 2/3. So 5/3 plus 1 plus 3 is the area of that rectangle. So that list right there you could actually do numerically to find the numerical answer, or we're going to punch it on our calculator soon. So we'll leave it for a second. But we're going to use that now to write sigma notation. That was the important part of this problem right now. So make our little sigma bar. Most of us are going to start at 0, which you don't have to, but 0 is a great place to start. 0 will give you rectangle number 1. A 1 would get you rectangle number 2, and a 2 would get you rectangle number 3. So we finish at 2. 0 to 2 would be 3 rectangles. Anything in here that got repeated, write it. So 4/3, the square root radical symbol, the +1 at the end, and the +3 outside the radical symbol. That was all the stuff that was repeated. The changing number, which is this guy here that I'm underlining, gets replaced in our sigma notation in the form of mx plus b. What those numbers are increasing by each time, that is the m, which is 4/3, and it just so happens that that 4/3, or that m right there, is always the same as the width of the rectangles. And then the b value is always the first number of these changing numbers, in this case the -1. We just stick it at the end. That's the b value. So if you were to plug 0 in for that x right now, all of this would just become this first rectangle. And if you were to plug 1 in, you would get this middle guy, and plugging 2, you'd get the bottom guy. So here's sigma notation. You can certainly simplify it if you want to. Obviously you can see those guys cross off, so you could just have square root of 4/3 x. But you don't have to. Mine will look just like that because I don't want to erase it and combine like terms. I'm kind of lazy. We need to punch this on our calculator, but we're going to do that at a different time right now to actually find the area. So I'm going to turn it over right now and do number 4, which I've started to graph just to save some time. It says that I need to make 4 rectangles in the gap from 0 to 5. So 5 is the gap. We're doing 4 parts, so 5/4 is each gap, or 1 1/4. So if I went to 1 1/4, then I get to 2 1/2, then 3 1/4, and finally 5. When I do right-hand endpoint rectangles, I start from the right side because it's easier for me. I slide up till I hit the graph from the right side, then I slide left from there, and then back down on top of that first gap. Up till I hit the right, slide across, and down, so that all the rectangles are hitting the original graph in the top right corner. Now, rectangle number 1, always go left to right there. It has a width of 5/4, and now we need to plug in the x value into the original equation, which is the upside down parabola, that will tell you how tall it is, which in this problem, it's the right side of the rectangle. So we need to plug this x value right here where I'm pointing into the equation. It'll give us this y value on the graph, and that y value is the length of the rectangle. So what is this x value? It's 1 1/4, or 5/4. So I'm going to write the original equation with 5/4 plugged in for the x. That would be the expression for the area of rectangle number 1. Let's do one more, and then we can see how we really don't need to write all of them out. Here's rectangle number 2. Its width is also 5/4, and now we need to plug into the original equation the x value that tells you how tall it is. Well, it wasn't this left side because that got us that height. We need to get all the way up to here, so we need this x value. And this x value right here, if you add 5/4 to that 5/4, you'd be at 10/4, which is 2 1/2. So you plug 2 1/2 into the original equation, and you get the area for rectangle number 2. So I'm going to stop right there, even though there's 2 more, because we can go to sigma notation with just 2 pieces of information, with just 2 rectangles written out. Starting at 0, we would finish, because there are 4 rectangles, we would finish at 3. 0 to 3 would be 4 rectangles. What got repeated in the 2 that I wrote? 5/4 was there, this parenthesis, negative 1/2, this parenthesis. Now I'm at the changing number. Remember, the changing number gets replaced with mx plus b, so I'm going to leave some space. Stick my -3, the squared, and the +6 at the end. And now let's go back to that mx plus b. What did these numbers here go up by? Well, it was 5/4, which was, again, the width of the rectangle. Hopefully you recognize that pattern. And now, by choosing 0, the b value here is just the first number of those changing numbers, which is 5/4. Feel free to combine those if you want to. I never do, so I'm going to leave it like that, box it. There's sigma notation. So that was the answers to numbers 2 and 4 on Doug.